The lesson objective of this video, students will find the areas of triangles and parallelograms. So first we'll talk about parallelograms. The bases of a parallelogram can be either pair of parallel sides. So for instance, if I think of these as being my bases, I could do that, or it could also be these parallel sides that are my bases. So it could be the top and bottom, or the two sides. When I'm talking about the height of a parallelogram, I'm talking about the shortest distance between the bases. And the shortest distance means that it has to be perpendicular. So in other words, the height will always be perpendicular to the bases. So in the upper parallelogram, the height would look something like that. But in the lower one, if I'm using the sides as the bases, then my height's going to look something like that. So whenever I want to find the area of a parallelogram, or a rectangle, which is just a special parallelogram, I take the base times the height. The area is just the base times the height. Okay, you're going to want to memorize that. So in this figure, I would use this as my base, and this is my height. And for a rectangle, it's pretty straightforward. Base and height are pretty much the same as your length and your width. If I have a square, it's also the base times the height, but since all the sides are congruent on a square, I can also just say that the area is the side squared. And that's actually where that expression comes from. So the side times the side, because all of them are congruent to each other. So if we look at example 1, I'm going to find the area of parallelogram ABCD. So I notice they've given me a lot of numbers here. So there's actually a couple different ways I could do this. I could choose to use 9 as the base, and so perpendicular to that 9 is this height 4. So I could say the area is base times height. In this case, 9 times 4, and that equals 36. But we also had another option. If I use the side as the base instead of the bottom, this is perpendicular to it, and so I could have also found it using those two. In that case, 8 times 4.5, and it still comes out to 36. So it doesn't matter which one you use, as long as you always look for your perpendicular height and base. They have to be perpendicular to each other. You don't want to get that mixed up. Alright, and looking at another example, we're going to find the area of this parallelogram. So again, I want to find my base and my height. And so the ones that are perpendicular, here we have the base and the height, so it's the 17 and the 7. that I need. This 10 is just extra information. They're trying to throw you off, so don't let them do that to you. So the area again is just base times height, and so 17 times 7, and so that would be 119 square units. So now we have a triangle. Well, suppose I have, off on the side here, suppose I have a parallelogram. If I cut that parallelogram in half, what do I have? A triangle. So the area of a triangle is just 1/2 of the base times height. Or if you prefer, you can think of it this way, base times height over 2, whichever is easier for you. And again, remember that the base has to be perpendicular to the height. So if we look at an example here, we're going to find the area of this triangle. So I need to figure out the base and the height. So here's my base. So it's going to be 45 plus 21, and my height 28. So 45 plus 21, the base is equal to 66. So the area is 1/2 the base times the height of 28. And that comes out to 924 square units. Area is always going to be in square units. Sides and perimeters are in linear units. Area is in square units. Okay, area congruence postulate. If two polygons are congruent, then they have the same area. Which makes sense. If they have the same dimensions, they're going to multiply to the same area. And then the area addition postulate says that the area of a region is the sum of the area of its non-overlapping parts. The sum of the areas of the non-overlapping parts. Okay, so what do I mean by that? If we look at example 4, I can see that I don't have just a straightforward parallelogram or triangle. Instead, I have this odd-shaped thing, which I can think of as actually two separate shapes. If I think of cutting it there, I've got a rectangle on top and a square on the bottom. I know that this length here is 5, and since they add up to 9, that means that top portion must be 4. And so the rectangle on top is 4 by 9, and then we have the square on the bottom, 5 by 5. And so it's just a matter of multiplying those together. 4 times 9 is 36, 5 times 5 is 25. When you add those together, we've got 61, and that would be meters squared. All right, let's take a look at another one. Now I have a square and a triangle together. So I need to basically have the area of the square plus the area of the triangle. Well, I can see that the sides of my square are all 16, so that means this side on top is also 16. So to figure out the height of the triangle, I know it's going to have to be the whole length 40 minus 16. That leaves 24 for the height of that triangle. So I'm going to use this side as my base for my triangle, and then my height of 24. So let's first figure out the area of the square. The area of the square is going to be the side squared, and then the area of my triangle is going to be 1/2 base times height. So half of the base, which was 16, times the height of 24. And so 16 squared is 256, and half of 16 times 24 comes out to 192. So if we add those together, the area of the entire figure is 448 square units. All right, one last example here. On this one, we're just going to find the shaded area. So in this case, what we have basically is we've got a rectangle, but then we are subtracting a triangle from it. So if we look at the area of the rectangle, it's just going to be base times height. So that would be 15 times 7. And from that, we have to subtract the area of the triangle. And so the base of my triangle is 15, and the height is given as 3. So half of 15 times 3 will be the area of my triangle. So if we do 15 times 7, we get 105. And half of 15 times 3 comes out to 22.5. And so that means we have 82.5 square units for the shaded area. And that concludes this video. Thank you.